Hey, hello, and welcome to today's GFG problem of the day. Count possible ways to construct buildings. Hope you all are doing well. So let's see the problem through an example, right? So what the problem is saying is there will be n plots given, right? Let's consider n as 3. Okay, so there will be a road and either side of the road, if n is equal to 3, right? N means n plots given, right? So either side of the road, there will be 3 n plots, right? So if n equal to 3 is given, so on one side of the road there will be 3 plots, and on the other side of the road there will be 3 plots, right? Now what they're asking is we want to find the number of the possible number of ways to construct buildings such that no two buildings should be consecutive. Okay, no two buildings should be consecutive. Now, so let's see. For example, if you consider this particular part, right? So what are the possible number of ways to construct the building? First of all, the total number of ways, right? 2 raised to 3, right? As there are 3 places, right? So 2 raised to 3. How? So let's consider building, right? BBB, then BBS, right? Then BSB, then BSS, right? Then what? SBB, SBS, SSB, and SSS, right? S is nothing but space. B is building. Okay. Now, out of these total combination, what are the possible combinations? This is not possible combination because we cannot have two consecutive buildings, right? This is a condition given. We cannot have two consecutive buildings together, right? So this is also not possible. This is possible. There is a space between two buildings, right? There's a space between two buildings. Then this is possible. 1, 2, right? This is not possible. 3, this is possible, right? 4, this is possible. This is possible, right? 4 and 5. So there are 5 ways, right, wherein we can construct either construct building or not construct building, right? So here there are 5 ways without two consecutive buildings, right? We saw we cannot have two consecutive buildings. We cannot have like this, right? That's a condition given. We need to have space between the two buildings, right? So on one side of the road, it is what are the possible combinations? 5. We can build buildings in 5 ways, right? Similarly, on other side of the road, right? Right, there'll be 5 combinations, right? There'll be 5 combinations. Now, so now I can build building over here and here because there's a space, right? We cannot say that these are two consecutive buildings, right? So if we consider, right, n equal to 3 on this side, n equal to 3 on this side, the total number of ways will be 5 into 5. Okay, what are the total number of 5 into 5? That will be 25 number of ways, right? 25 there will be combination of 25 ways, right? So this is the output here. Okay, 25. So if you see, right, for example, if n is given, n equal to 1 is given, right? That is 1. So what are the total number of ways, right? Either you construct a building or you don't construct a building. You keep it as is, right? So there are 2 ways. When n equal to 2, right? If there are 2, right? So 2 plots, right? So either you can have what are the total number of ways? B, B, right? Then B, S, S, B, and S, S. This is not possible. We cannot have two consecutive buildings. This is possible, this is possible, this is possible. So n equal to 3, right? That we are considering on one side of the road, right? On one side of the road, right? So when n equal to 1, there are 2 ways. When n equal to 2, there are 3 ways, right? 3 ways. And when n equal to 3, there are how many on one side of the road? 5 ways. We saw, right? 5. We saw 5, right? We saw 5. So are you seeing the pattern here? When n equal to 1, 2, n equal to 2 equal to 3, and n equal to 3 equal to 5, right? So simply what we are doing is the current is the addition of the previous two, right? Addition of the previous two. Similarly, when n equal to 4, it will be on one side 5 plus 3, 8. 8 ways. And then similarly, so we are going to use this intuition, this pattern, right? And finally, whatever is, for example, if n equal to 4 and it is on one side, it is 8. So we're going to return 8 into 8. 8 into 8, that is, right? That is 64 ways. Okay, 64 ways. So this is the intuition. When this, let's see the problem. Let's see the solution now. So see, you know, right? What we're going to do when n equal to 1, we are going to take, right? N equal to 1, we saw it is 2, right? It is 2. And n equal to 2, it is 3. We are taking over here. N equal to 3, it is 3. Simply if when n is 1 given, then simply we are going to return 2 into 2, right? That is double, right? Then we have to consider both sides of the road, right? Both sides of the road. When n equal to 2, we are returning 9. That is 3 into 3. 3 into 3, right? When n equal to 2, we saw n equal to 2, it is 3. So on both sides of the road, we are going to return 3 into 3, 9. Now, if n is greater than 2, right? So what we're going to do is we'll go till n, right? And as I said, the current will be the addition of the previous two, right? Addition of the previous two. If n equal to 3, a equal to 2, and b equal to, right? So the previous one, uh, a equal to 2 and b equal to 3, right? So we are going to add, right? We saw here 5 is equal to 2 plus 3, right? The previous two. And similarly, we are going to assign a equal to b and b equal to c, and we are going to do the calculation in this way. Okay, in this way. And finally, what we are doing here is we are returning on both sides of the road. So C, it contains one side of the total number of ways on one side, right? We have to return both sides of the ways, right? On both sides of the road. So we're returning C into C, right? And modulus, because the answer can be very big, so we are using modulo here, 10 raised to the power 7. Okay, so this is a solution. the Java and C++ code is exactly the same. Okay. I hope you have understood the solution. Let's submit it. So yes, it is accepted. The solution is accepted, and we have given the most optimized solution. The expected time complexity here was O of n, right? Okay, this is O of n only, but space optimization we have done. The expected space complexity was O of n. We have done in O of 1, right? So this is the optimized version of dynamic programming. Okay, what we have done. Okay, so I hope you have understood the solution. Please, I would request you to subscribe to my channel if you have really liked the solution. Thank you very much. Have a happy, healthy, and a great day. Thank you.